Hey guys, it's Tamesh here. Welcome to another episode of React Native Tutorials. Today we are going to recreate a classic game called Snake. Before we start, a quick recap of what the game does. It's relatively simple. So you control a snake, and your goal is to eat food. If you eat food, you grow. If you hit the wall or hit your own tail, you die. So this is how it looks like. Very simple. This game is very nostalgic to me because this was probably the first game I ever wrote and actually I ever sold. So I made a version of this in first year of high school, I believe, and I sold it to a couple of my classmates. So yeah, it's pretty nostalgic. All right, let's get to it. So in order to build this, we're gonna use, to my knowledge, the only game engine that exists for React Native, and it's called React Native Game Engine. It's a very basic game engine. It does implement a generic game loop. It takes care of handling touches. It has some exposed methods to send and receive events backend from the game engine to the main application. So it's a very good starting point. A couple of people already built some cool games for the App Store for it. Someone actually made Donkey Kong, which is pretty amazing. Installation of it is very simple. Just do an npm install and it's all done and ready to be used. I'm gonna link this cool project in the video's description. But yeah, let's get to it. So I already set everything up, so I have a new project started with Create React Native App, and I also installed React Native Game Engine, and I got rid of the boilerplate code. So we have a basic container with black background, and it's running here in our emulator. Okay, so let's break down this game. How does this work? So basically, your snake has a head that you control. In this example, I'm controlling with my keyboard, but obviously on a mobile phone there is no keyboard unless you attach some external device to it. So we either have to use swipe gestures or some on-screen controls. Anyway, you control this head, so that will be one of our entities, and this food randomly pops up at at a random location on the screen, and when you eat the food, the snake grows. The tail, of course, follows the head, and that's something we need to code using React Native Game Engine. All right, let's get to it. So before, as per usual, we're gonna create a new file for our constants.js, export default constants equals import dimensions from React Native, and we're gonna have a max width. I might not even use this. I'm just I got used to it. Get screen dot width, and I need the same for height. Max height. Okay, cool. What else do we need? So let's go back to this game. So the game is played on a grid. I'm gonna set up a, let's say 15 by 15, yeah, 15 by 15 grid for this game. So I'm gonna do a grid size will be 15, and let's set size for each cell. So I'm gonna do cell size 20 points. Okay, cool. So let's start by drawing our board. So I'm gonna set up here at this board board size to be constants dot grid size times constants cell size, and I need to import my constants. Import constants from constants. Cool. And let's draw something. So I'm gonna add a game engine. I need the reference for the game engine. So this engine equals null, and here I'm gonna do ref equals ref this dot engine equals ref, and I'm gonna set a style for it. It's gonna have a width this dot board size, height this dot board size. I have to add flex equals null because the code has hard-coded flex equal 1, which makes your life a bit more difficult when it comes to this. And I'm gonna do a background color of white, and that's gonna be our game engine for now. And reload this. Cool. So we have a playing field essentially. Okay. So the way game engine works, you need to define two things: set of entities, which will be a set of components basically to be rendered on the playing scene, and you have to set up your they call it the systems basically. So game engine implements a game loop. So pretty much at 60 frames per second, at every tick, they're gonna call the set of the list of functions you define as systems. So we're gonna need a set of systems, and we're gonna need a set of entities to be drawn on the screen. So let's start with entities. For now, so entities is actually an object. So I'm gonna define head entity, which so these parameters here will be passed in as props to my component, the head component that I will later define. Okay, so I need a position which at start will be 0, 0. So let's start at the top left corner, and I need a size which will be constants dot cell size, and renderer which will be a head. Okay, so let's create a new file called head.js, and here I'm gonna do import React. So this is normal component, normal React component. React import. I'm gonna need a view from React Native. Export default class head extends component constructor props. It can be a functional component actually, but we will see. And we need a normal render. So this should be very simple. So let's get the x value, which will be this props dot position 0, and we're gonna have a y which is 1, and let's return a view which will be style equal. So it will have a width which is this props dot size, a height which will be this props dot size, background color. Let's make it boring. Actually, let's make it red. And and this will have a position absolute and left, which will be x times this dot props dot size, and the top, which is y times this dot props dot size. Okay, and I think that is it. Okay, so we have a head. Let's import that. Import head from /head, and that should. Yep. So we have a head rendered on our grid. If I put it to 10, enable host reloading. Yeah. So okay. Now okay. Cool. Okay, now let's define our system. So you can define one or many systems in React Native Game Engine. We're only gonna need one, which basically gonna be your game loop. So systems equals I think it receives a list, and I'm gonna call it game loop. Import game loop from /game loop. Cool. And new file game loop.js. Okay. So again, constants from /constants. Okay. So const game loop equals the way it's set up. It's by default it's definitely need to accept the list of entities. These are the entities on every tick we are going to manipulate, and then there are a bunch of optional things. We're gonna need touches probably if we want to do swipe based. We're gonna need events, so I'm gonna talk about these later, but essentially you can send and listen to events to and from the game loop and between the main application, and something called dispatch. So dispatch is the way how you send and receive, actually just send events and return entities. Okay, and export default export game loop. Okay, so we have game loop implemented. This is not this is not a function. That is funny. Okay. What is that? It's coming from game engine.js. Systems equals game loop. That should be correct. And my brackets are correct. Entities, touches, and dispatch. Okay, let me stop the recording and try to figure this out. Okay, so I think I figured it out. So essentially, the order of these parameters do matter, which is super weird, but it is what it is. All right. So back to building this game. So what happens is at every tick. So if I do a console log tick here and do debug.js remotely. Something is not okay. All right, I need to do further debugging, so I'm gonna pause the recording again. Okay, I figured it out. So basically, I was an idiot as per usual, so I imported game loop straight, but I didn't export as default, so that's why. So back to where we were. So I added a console log tick in our game loop, and you can see it's being called like many times per second. I believe it runs on full 60 frames per second, but I couldn't find anything in the documentation for that. Okay, so let's think about this. So basically what we want to do is start moving our head to a general direction, well, by default in the x direction towards the right, and if the user gives us some sort of input we change the direction. So I think what we need to define here is an x speed, which will be by default 1, and the y speed, which will be by default 0. And here, in the game loop, what we should do is, first of all, let head to be entities dot head, and we can just do head dot x head dot x equals head plus equals head dot x speed. No, sorry. Head dot position 0 equals head dot x speed. Okay, so what happens? You seen it went really quickly. So I think we need to slow things down. Now, Game Engine allows you to define your own timer method or timer class. I couldn't figure it out yet how to do it, but I came up with a hacky way, which is defining an update frequency equals 10 and a next move equals 10. And what we can do here is head dot next move minus equals 1. If head dot next move equal 0, then head dot next move equals head dot update frequency, and we can do head dot position 0 plus equals head dot x speed, and head dot position 1 plus equals y speed. So what we do here really is we only update the position of the head every 10 tick. So how does that look like? Cool, much smoother. Okay, that is very cool. So what we should do here now, well, first of all, let's make the movements stop when you hit the wall. So if, and this will be a big if, head dot position 0 plus head dot x speed is less than 0 or is greater or equal constants dot grid size, or same thing, sure, both of these things but on the y, on one y. So if this happens, we have to do a game over. You hit the wall, otherwise move it. Cool. How does it look like? Okay, so when we hit the wall, it stops updating. Amazing. And let's add some controls. When I originally made this game before this video, I tried with swipe controls, but it worked really well in the emulator. But when I put it on my iPhone, it was very well. It wasn't really user friendly. So I decided to actually do on-screen controls. So I'm gonna do a view style equals styles dot controls, view style equals styles dot control row, view style equals styles dot control. Actually, let's just do this. So I want to kind of create a joypad kind of situation. Control, but this one will have null and okay. Cool. So let's define this. Controls will be width 300 height. This won't be a very beautiful game, to be honest, but column, then control row width 300 height 100, flex the direction row, and align items center, justify content center, and control will be this thing but with 100 with background color blue. Alright, what do we have here? Okay, we have some sort of joypad. I'm gonna import the touchable opacity to make those actual buttons. So I'm gonna do an on press because anonymous. Okay, so those are touchable. And what I want to do is send in an event. So the way you do an event is through the React Native game engine's dispatch methods. So you can do this.engine.dispatch. So this is our up button. So I'm gonna do type move up. Okay, and I'm gonna copy this whole thing here, So this is our left button, left, sorry, this is our right, and this is our down. Okay, so this will fire an event and our game loop is already listening to it, so it has this events list. So you can do here if events.length for let e equals 0, e less than events.length e plus plus. If events e dot type equal move up. I only want to move up if I'm not moving down. So and head dot y speed not equals 1, then head dot y speed should be equals minus 1, right? As if this type is moved down and it's not already moving up, then it should be moving down. As if move left, if x speed, so if x speed is not equal 1, then the x speed should be minus 1. And finally, if it's move right, well, free x speed. If it's not equal minus 1, then it should be minus 1. Okay, cool. I think, oh, that was interesting. Let's see that again. Oh, we are going, oh, okay, we also, of course, so head.x speed equals 0, x speed 0, y speed 0. So, generic rule in Stake, the head can only move in one direction at the same time. Okay, cool, so we can control it. On game over, I want to just, so we already have the dispatch here, so we can just dispatch a type game over. And in our main loop, what we can do is define an on event equals this dot on event. If e dot type equal game over, okay, hey, game over, but it's fired all the time, which is not good. So we're gonna set a state which is running is true, and game engine has this running parameter, which essentially you can stop the game loop. So you can do this set state running false. Okay, so okay, so it only fires the game over once. Okay, on to our next entity. So we have to render render food. So what do we need for the food? So food gonna need a position which will be random number. It doesn't have speed, doesn't have any of this. It does, however, has a size, and it has food as a renderer. So I need to write my favorite function that I can never write, so I'm gonna cheat here, which will be random between min and max, and return math.floor math.random math.random star max min plus 1 plus min. I can never write this function, which is annoying. Okay, so this dot random between 0 and constants dot grid size -1, and same for this. And we need a food. So food will be, the render for food will be pretty much the same as head. It's just different color. It really could be the same component, but let's keep it separate. So food, let's make it green. Okay, and let's go here. Yay, we have food here, but nothing happens when we collide. Okay, so let's do the collision. So in our game loop, here, if it's not game over, what we need to do is here, I guess, if head.position 0 equal food. Actually, I need food first. Let food equals, and it is food equal food dot position 0, and then head dot position 1 equal food position 1. Okay, so keeping food. First of all, we need to do here that grow tail. So we gonna deal with that. But also we need a new food position. So food dot position 0. I'm gonna be lazy, just copy paste this. So it's random between, and the same thing here. And same for position 1. So if we eat the food, if I can control this, yep, that should render it. Okay, awesome, amazing. And okay, finally the last element for this game is it's kind of tricky, but it's not exactly rocket science. Tail. So we have to define a tail. Which actually won't have a position. What it's gonna have is, it has a size which will be the cell size essentially. So a tail, if you think about it, is just a series of cells. It will have elements, so the position of each element will be stored here. Elements and the renderer, which will be a tail. Okay, and let's import it. And new file, tail.js. Okay, so tail is doing this. So it's a bit different, and I'm gonna need constants for it. Import constants from /constants, and I don't need this. So I want to render a cell for each element of the tail. So let tail list equals this dot props dot elements dot map. It will have an element and an index, and this should return a view with a key, of course, and the style, which will be so with this dot props dot size, this dot props dot size, background color. I'm gonna make it nice and gray. Position absolute, and kind of this, but instead elements 0 and element 1. Okay, so this will give us a list of tails, and what we need to do is put it on a put it inside a view which will have the same size as the whole board. So constants dot grid size times this dot props dot size, and height constants dot grid size times this dot props dot size, and view, and render tail list in between them. Cool. Tail. Okay, so obviously we don't really have a tail, so nothing really should happen except the build is not working. What is it complaining about? What will not register? Okay, so in this case I have to kill this. Come on. I have some sort of error here. Okay, back to tail. Oh, it doesn't hurt. What's wrong with you now? This looks correct. Sorry about this. Okay. Okay, so of course it doesn't do anything because we are not growing the tail yet. So what we should do? So in our game loop, when we hit the food, we should grow the tail. So first of all, I need to grab the tail. Tail equals entities tail, and tail.elements equals so I want to add food.position 0 and food.position 1, and concat it with tail.max, I guess. So basically I want to prepend the food position. And okay, But in this case, what's gonna happen is it actually just stays there, right? So we have to make it follow on each tick essentially. Okay, so how do we do this? Basically, on each tick we should move the current head position to be the first position, and chop off the last element of the tail, if that makes sense. So what we can do is tail dot elements equals same thing what we did with the food, head dot position 0, head dot position 1 dot concat tail dot elements dot slice 0 minus 1. So if you think about it, what we do is we add one element at the beginning. If tail dot elements was empty, then this is actually one element, and then we chop off the last element. So you will end up with 0, and then this should just work, I believe. Hey, we have a tail that follows us. Cool. Alright. Okay. So one thing we forgot is the player should die when they hit their own tail. So that's super simple to do. For let e equals 0, e less than tail dot elements dot length e plus plus, and we can do if head dot position 0 equals tail dot elements e 0, and then 1 equals this, then we should just dispatch game over. Okay, so that's takes care of that. Cannot read. Okay. Cannot read property 0 of undefined. Because I can type position. Okay. It's actually really difficult to control this on the emulator, especially that my Magic Mouse is acting up, but it's actually not too bad on a actual phone. Okay. I'm literally chasing my own tail. Anyway, I assume it works. One thing I want to add here is just a simple button. Button title equals new game on press equals this dot reset, and import button and reset via B. So what we want to do here. So React Native Game Engine exposes this thing called this.engine.swap. So it swaps out the entities. So you can just redefine these, and this.set state running goes through. So now in case we die, we can just hit new game and it gives us a new opportunity. Alright, cool. I think this is it for today. It's obviously not perfect and it's hacky. It's a proof of concept. The code is on GitHub, link below in the description. I also gonna link a Medium post I wrote about this topic if if you want to dig deeper into why I'm doing certain stuff. But yeah, this is it for today. Please, if you like the video, leave a like, leave a comment. If you are not yet subscribed, please do subscribe. I'm trying to release at least a couple of videos every week, and yeah, so if you want to be notified about the new content, just subscribe and hit the bell button. Thank you very much. Have a nice day.